Good morning, friends. Myself, Dr. M.H. Annaya. And before I start today's YouTube video, I'm very happy and glad to announce that I have completed 200 videos as on today, and there is tremendous response from people like you. And I have got plans to make minimum 1000 videos with the experience of 42 years I've got in teaching the subjects like machine design, engineering, graphics, strength of materials, etc. Friends, in today's session, we are going to have the section of a square prism. Friends, as the name indicates, a square prism will have a square bottom and a square top. These being connected by number of rectangles. A square prism will have four such rectangles on the lateral surface. A pentagon will have five such rectangles. And remember, friends, the dimension of these will be the side of these and the height. This height is equal to height of the solid or length of the axis, and side of the base will be equal to the side of that figure. Friends, the question for today's session reads like this. A square prism of side 30 mm and axis 60 mm long, resting on one of its square faces on HP. Friends, before we commence the problem, I advise you students to go through the problem twice, very slowly, analyze the contents of the question, and then only you can start working out a problem. So, in the initial stage, you have this square prism which is placed on HP with two of its shorter sides equally inclined to VP. Friends, when you take up the square prism, there are 1, 2, 3, 4 shorter edges for the square prism, and this is in the question. It is resting on HP with two of its adjacent sides equally inclined to VP. That means, friends, one of these, suppose say this is AB, AB is at an angle to VP. So likewise, the adjacent side, this also will have the same inclination. That is to say, the same problem initially can be stated in three different ways. The first one is one of the shorter edge of the bottom face is at 45 degrees to VP, or two of the shorter edges are equally inclined to VP, or in the third way, it can be stated that all the four shorter edges of the bottom face equally inclined to VP. So this is how it can be specified in different ways. Now the object or the solid is resting on HP on its bottom face. Top face, bottom face, both are square faces only, such that one of the or two of the edges are equally inclined to VP. So I am going to keep the solid on HP. Say my palm is the HP, such that two of these base edges are equally inclined to VP, or two of the adjacent vertical faces on the lateral surface equally inclined to VP, and obtain the top and front views. Friends, in the top view, you are going to get a square with all the sides equally inclined to XY or equally inclined to VP. And in the front view, you will be able to see two rectangles, these two colored rectangles. So let me place the object on HP with two of its base edges equally inclined to VP and obtain the corresponding top and front views of the solid initially. Friends, this is how the prism looks in the top view and in the front view. Let me label all the corners and the edges. So this you should remember, these are 45 degrees. Both the sides are at 45 degrees. So I'll mark it as A, B, C, D. And if you just join these diagonals, they meet at a common point, say O. So let me mark this in the front view, A dash, B dash, D dash, C dash. For the bottom face, C1 dash, B1 dash, D1 dash, and this is A1 dash. Axis is perpendicular here. And friends, a double marking you should do. A comma A1 is the vertical edge A. This is B comma B1, C comma C1, D comma D1. And the height of this object or this solid is given to be 60 millimeters. So I just mark the dimension 60 adjacent to the front view. Friends, this is the top and front views. So initially we have written up to the two of the shorter edges equally inclined to VP. And then comes the section plane. Friends, it is very simple. A section blade or section plane or a section or a cutting edge can be taken to be equal to a very thin sharp blade which is able to cut the solid. Friends, here this section plane which is normal to VP is very important, friends. When the section plane is normal to VP, means perpendicular to VP, it could be like this, a vertical section plane perpendicular to VP, or it could be like this, a horizontal section plane or a section plane at an angle. So whenever the section plane is perpendicular to VP, it is seen as a line in the front view. So friends, as per this question, the section plane which is normal to VP and inclined at 45 degrees to HP bisects the axis of the solid. What does it mean? The section plane, while inclined at 45 degrees, cut the solid bisecting the axis. The axis is, this is O dash and this is O1 dash. O dash O1 dash is the axis, this line, and we have to mark the center of that. Say this, the center means 30 mm from here. I can show here. This is 30 mm. The midpoint of the axis O dash O1 dash, and mark a section plane passing through this midpoint. Say I will just write a line here. Suppose this is the section plane. I mark it as SS. SS is the section plane which is perpendicular to VP and is inclined at 45 degrees to HP, bisecting the axis of the solid, dividing the height into two equal parts. So friends, now after it is being cut by the section plane, the upper part above the section plane, that is this portion, is thrown out for the purpose of drawing the sectional view, and the portion that is remaining is darkened. So bottom portion from the base till that height is retained. Friends, this darkened portion will give you the front view of the solid, and you have to darken only this bottom portion, this much. This is to be shown, to be retained and shown by very thin lines just visible. Friends, now the object is being cut by the section plane. Let us see how it looks after this is being thrown out. Friends, I will just mark those points. The vertical edge AA is cut by the section plane here. So AA is here. So we'll call this as point number 1. Likewise, BB and DD are also cut. Wherever may be the section plane, you get for DD a point here, and for BB you get another point here. I will call this as 2, this for the point 3, and for this as point 4. So we have got all the 4 vertical edges, A dash A1 dash, B dash B1 dash, D dash D1 dash, C dash C1 dash, are all cut by the section plane. So there are four edges that are being cut, hence you get 4 points in the top view. So friends, we have got all the 4 points, and after getting that, darken this 1, 2, 3, 4 by lines, by dark lines. So this is the top face, bottom face. Then hatch it, section it by lines drawn at an angle of 45 degrees to the horizontal. Friends, this view, the square, along with this hatching, the sectioning, will give you sectional top view, STV, of the solid. Draw the sectional top view, draw the front view. We have completed 2 parts of the question. And this is true shape of section. Friends, what is true shape of section? Shape of section is nothing but the mirror image of this cut part when you hold a mirror parallel to that. So it's a mirror image. So to get that, there is a procedure to be followed. Before that, let me transfer these points 1, 2, 3, 4 onto this. So this is 1, this is 2, comma 4, and this point is 3. So we have this 1, 2, 3, 4 points. So to obtain the true shape of the section, there is a simple procedure to be followed. And here what we do, we write a line parallel to SS at a convenient distance above this, somewhere. So I will just draw a line parallel to that. So this line, whatever I had drawn, is parallel to the section plane SS, and from these points 1, 2, 3 and 4, I draw vertical lines or lines perpendicular to that. So this is one line, this is a second line. From all this, so we will draw these lines. Second line, from here you get 2 more. So friends, now we have to get all these 4 points on this. So you should remember, these are all perpendiculars drawn to this line. So SS is parallel to this. This line drawn is parallel to it. Friends, we will obtain the true shape here by taking the points one by one. Friends, if you just look at the board, point 1 is at this distance from XY. So I mark this distance on this. So I would say I am getting this gap. This distance is equal to this. That is, all the distances for the true shape are to be measured from XY. So this is point 1. Then at the equal distance from C, from here, you have got point number 3. So on the other end, if you can simply extend this, and this will be your point 3. Then friends, 2 is away. How to get the distance of the point 2? 2 is this much. From the XY to this much is 2. This is point 2. You got 3. Finally 4. 4 from the XY to point 4 in the top view. So that is somewhere here. A small distance. So we got friends 4 points. 1, 2, 3, 4. And we'll join all these by straight lines. So I just join 1 to 2, 2 to 1 to 4, 3 to 4, 1 to this. Friends, we have got this figure, and this figure is the true shape. So before that, let me section that. So we are going to draw lines parallel to these edges. They are at 45 degrees to the horizontal. Obtain this, friends. This figure will give you the true shape of section. TS is the true shape of section. And also they have asked in the question, name the true shape of section. So what is the name of that figure? Very obviously, you're all engineers, you know it. This is a rhombus. The true shape of the figure is a rhombus. And friends, after that, you can notice some important things here. That is, number one, the distance of point 4 is this gap. Distance of point 2 is this. Or in other words, whatever the gap you have 2 to 4 is this 2 to 4. So here in this problem, you can just see what's the measurement of 2 to 4. Same thing you are marking here. And since it's the rhombus, the opposite sides are parallel and equal, and opposite angles are also equal. And one more important thing is, friends, when the position of the section plane is given, you can obtain the true shape. The converse is also true. That is, if you are given the true shape of the section, you should be able to obtain the location of the section plane. Friends, here one more important thing you should remember. This measurement 2, 4 is the diagonal of that square in the top view. So in the next video, I am going to give you the dimensions of the true shape and ask you to find out or to locate the position of the section plane. Friends, I hope you are happy with the presentation made on this section of square prism. Friends, please continue watching and share this information with all your friends and thereby help me to grow and have a wonderful day. Thank you very much.